It's always so lovely to host you every Wednesday of the month right here at Digital Earth Africa. Greetings, leaders from the African continent and across the world. Welcome to today's live session. It's so lovely to have you with us. My name is Maud Nale. I'm the communications lead here at Digital Earth Africa, and we want to welcome you, as we always do, to these live sessions. We alternate between English and French every Wednesday from 11 a.m. GMT, and so we're so happy that you could join us today. We are going to be talking about a very interesting topic today as we introduce NDVI Climatology and Anomalies using Digital Earth Africa Sandbox. NDVI climatologies may be used for many applications, including identifying extremities or anomalies in vegetation condition, identifying both long and short-term changes in vegetation condition, and as an input into machine learning processes for land use classification. To tell us more about this and its application, I'm excited to welcome onto the virtual stage my fellow colleague. It's been a while since we've seen him present at a live session, but we're equally excited to have him with us. He is the technical manager right here at Digital Earth Africa. Please join me in welcoming onto the virtual stage, Edward Boamah. Edward, the virtual stage is yours. Over to you.
Thank you, Maud, for the introduction. Hello, everyone. It's a great pleasure to meet all of you once again. It's been a while, but today I'm very happy to present on the NDVI Climatology and the NDVI Anomaly. So before we go into the practicals, like going to the map session and also the sandbox about it, I'd like us to just talk about the NDVI climatology and what you can also expect from it. So I'll share my screen. Yeah. Okay. I hope everyone can see my screen. Okay, so what is the NDVI climatology all about? We first talk about it, then we move on to the NDVI anomaly also. So Digital Earth Africa NDVI climatology product actually represents the long-term average baseline condition of vegetation for every Landsat pixel over the African continent. So when I'm talking about the Landsat pixel, I'm actually referring to the Landsat 5, 7, and 8 that has been harmonized to generate this climatology over the period. And within the climatology, we have both the mean and the standard deviation for each calendar month. So with the product, if you check the data set, we have 12 images for the climatology. So if you come to the mean, we have 12 images. If you come to the standard deviation, we have 12 images, which represent the calendar month, so January up to December. The temporal baseline for this data is actually 1984 to 2020, as we talk about it. So including the Landsat 5, 7, and 8, bringing them together. That's actually based on the Landsat family. The resolution is actually 30 meters for this climatology. Okay, so we made mention of developing this product out of Landsat. So when it comes to the data set measurements, you have three different measurements for the data sets. We have the mean monthly. So this shows the NDVI calculated for all the available NDVI data from 1984 to 2020. Then you also have the standard deviation month. And it also talks about the standard deviation of the NDVI values from 1984 to 2020. And you also have the count. So the count actually shows the number of clear observations that was obtained when we were creating the mean and the standard deviation. And all these measurements have 12 images for each particular measurement that we talked about it. So when you talk about the mean, we have January to December. If you talk about the standard deviation for the NDVI climatology, we have January to December. Then also if you talk about the count, that's the clear observations. That one also we have January to December for this climatology measurement. But in respect of it, there is a limitation that we want all our users to take notice of when they are actually working with it, especially when it comes to the Landsat 5 imagery that we have. One of the issues that we had with the Landsat 5 was over the equatorial Africa, we had actually a poor data set for Landsat 5. And because of also cloud issues, it also makes it inconsistent. It became inconsistent. So anytime anybody wants to use the climatology for a study area, what we are recommending, but the user can also recommend another method that he wants to use, that you should make sure that the clear observation count is not less than 30 observations. So depending on wherever you are working with, please make sure that you look at the clear observation count for that particular area. Due to that, it can actually affect the results that you are going to contain. Depending on where you are working with, you can choose to go even lesser than that. But we just want you to make sure of this limitation of the NDVI climatology when it comes to when we are working with the Landsat 5 data set. Okay, so as you can see, there's some of the images of the NDVI climatology. That's from 1984 to 2020. And as you can see, you see the standard deviation and also the mean NDVI climatology for the whole African continent. So what are some of the uses of this NDVI climatology? There are a lot of uses of it, but one of the uses of it is the NDVI anomaly, which we'll talk about it very soon. From the introduction, I made mention of harmonization of both the Landsat 5, 7, and 8 to be able to actually generate the NDVI climatology. And actually, if you're actually interested in how this harmonization was done, if you visit the link that I've posted here, we actually give you the detailed explanation of how the harmonization was done, and also the notebooks of which also does the harmonization. So in case you want to also do a further harmonization for your study area using this product, you can actually visit that notebook and use it there. So by clicking on this link to actually give you access to the how the harmonization process was done to achieve the combination of these three products to generate the NDVI climatology. Okay, so one of the uses of the NDVI climatology was to derive the NDVI anomaly. So the NDVI anomaly service actually provide the estimate of vegetation condition for each calendar month. And this can be achieved if you have a long-term baseline condition. So one of the most important application of this NDVI climatology was to calculate the NDVI anomaly. So what we did was we wanted to know the vegetation condition for each calendar month, and you measure that one against the baseline condition for using a long-term period for that. So that's why you first derive the NDVI climatology to actually help us to be able to also derive the NDVI anomaly. So through the NDVI anomaly, we also have the standardized anomaly, which was also calculated by subtracting the long-term mean from an observation of interest that you want to work with. Then you divide it by the long-term standard deviation. That one also lets you generate the standardized anomaly for that particular period that you are working with. So as you can see the formula there, you have the NDVI, the month and the year that you want to work with, and it's measured for a month in the year. Then you also have the month, that's the long-term month from 1984 to 2020. Then you also have the long-term standard deviation. As you remember from the climatology, we have the NDVI for the month, and you also have the standard deviation for the month. And you also have to calculate the NDVI for that particular month and that particular year. Then you measure it against the long-term measurement and divide it by the standard deviation. That one will lead you to get the standardized anomaly for the area that you are going to work with. And a standardized anomaly also helps you to measure the direction and significance of vegetation change against the normal condition. That's why we're interested to also derive the standardized anomaly for this product. So if you have a positive NDVI anomaly, it actually indicates that the vegetation is greener than the average condition, and are usually due to the increase in rainfall within a particular region. If you're also getting negative values for the anomaly, that means the plants are actually under stress relative to the long-term average that we are having. So the NDVI and anomaly series actually will therefore actually help us to understand, first of all, the extent, the intensity, and the impact of drought on vegetation. So that's actually one of the main reasons you can actually use this NDVI anomaly continental service that Digital Earth Africa actually produce to do. It will help you to understand the extent, the intensity, and the impact of a drought within a particular area. So the NDVI anomaly also comes with measurements. Just as we talk about the climatology, it also comes with measurements. So the anomaly comes with the NDVI mean, which is actually the mean NDVI for a month. Then we also have the standard NDVI standardized anomaly. We also have the clear count. But mind you, with the climatology, it was over a period of years that has been combined to calculate the climatology. So with that one, we have actually only 12 images for each particular measurement. But when it comes to the NDVI anomaly, because that one we are dealing with a month and a year, it's actually over a long period of time. So once you go into the sandbox and the maps, we actually talk much more about how you can see this and how you can actually apply it within your area of interest that you are working with it. So as you can see, this is also the NDVI anomaly for 2017. Remember, for the climatology, it was just 12 images for the whole long-term period. That's from 1984 to 2020. But for the NDVI anomaly, it's for particular year, particular month. So what you are seeing here is just an example of the NDVI anomaly for 2017 and how you can actually see it being broadcast along the African continent. And you can actually also see from the Equatorial Africa, that's some of the areas, you have some mixing data across it. Yeah. Remember you made mention of the climatology because some areas there was inconsistency of data available. The data was very poor. So we decided to take some off due to that particular images that we have. So that's why you are seeing some mixing data there. But irrespective of that, you can actually also go for it and use that data. So these are some of the limitations of the NDVI anomaly also, which is not that much, but it's also available. So the coverage and reliability of the NDVI anomaly services actually dependent of the quality and availability of the NDVI climatology for the month of interest. So as we said, the Equatorial Africa, the service is impacted by the low quality of the long-term baseline and the low number of cloud-free images in that particular given month. So if the area of interest that you are working with, it seems that there is no much information for the NDVI generated, it was due to this. But for the NDVI anomaly generation, we considered area with clear clouds greater than 10. So we consider using more than 10. So if there's a clear cloud less than 10 for the location, you will take that particular area off for it. So these are the two continental services that Digital Earth Africa actually produce for us to be able to use to actually help us to measure the extent and the intensity of drought that actually happens within our area of interest that we are working on. Okay, so at this point, I would like us to go straight into the platform and see how we can actually work with the data set. A minute, let me just switch to the maps. Okay, let me share my screen. Due to internet, I just had to upload some of the images so that the internet won't play tricks on me. But nevertheless, this is the map section of the Digital Earth Africa, so maps of Digital Earth Africa, which actually help us to be able to visualize most of the data sets that we have across the African continent. And the NDVI and the anomaly are actually present here. So you just go through it and see how we can actually visualize it within the maps. Okay, so once you visit maps.digital Africa, you actually get it will come in the face whereby the base map will be showing the whole of Africa. You can actually change the base map on depending on how you want to work with. Normally, I like the black interface because it's easier to load very quickly. So if the internet is low bandwidth is very low, it can still load it up for you easily. But if your internet bandwidth is very good and very fast, you can play around with it. You can even go with the 3D terrain or the 3D smooth, depending on which one you want to use. But I would prefer to use the black, so that's why I'm using the black base map. Then you go straight to the explore map. So under the explore map, you can find the NDVI climatology and the NDVI anomalies under the vegetation. Thematic vegetation. So once you go into the vegetation section, the climatology is under the vegetation climatology. So you click on it. If it has already been added, you're going to see the minus sign. But if it hasn't been added, just as you can see the global mangrove watch, you're going to see the plus sign there. Because I've already added it to my map, that's why you can see the minus sign here. Also, if you click on it, on the right hand side, you see a description about the data set and how you can work with it. And the NDVI, mean NDVI and the NDVI anomaly is also under the same thematic area. We also have the monthly vegetation index, which is going to be the mean NDVI and anomaly, which I've already added it to the map. If you want to, if I click on the minus side to be removed, as you can see, if I click on the addition side to bring it back to the map. Okay, so once I've added the layers here, we have the two. So the first one that we are going to talk about is the NDVI climatology, which is actually down here. And let me put it on. If you click, you can easily toggle the layer on and off. You can easily toggle the layer on and off. So once I click on the NDVI climatology, you can see that we have the ideal zoom. If I click on the ideal zoom to zoom to the whole of the African continent, so you can see that the NDVI climatology actually covers through the whole of Africa. Let me just zoom it in so that you get some images showing up for us for the whole of the African continent. If you look at the stars here, you can actually see that you have the mean NDVI and you have it for January, February, March, April, all the way up to December. You can see that you also have the standard deviation for January all the way up to December. Then you also have the clear count for January all the way up to December. So the NDVI just have these measurements. So in all, the NDVI have about 36 images just present for it. And as you can see below it also, you can see the measurement that this is the mean NDVI, which for January, which is from 0 to 0.9. So as you can see at the top here, it has very poor mean NDVI, but you can actually also see some green pastels. So this is for actually for January. If I scroll to a month of April, you see the NDVI climatology loading up for April. So you can actually see it also loading up for April for that particular month. Let me zoom in a little so that it can actually load fast for the area that we are working, so that we can actually see with it what we are looking for. So that's it. You can also change if you want to see the standard deviation for that for a particular month. You can also go there, then click the standard deviation for that particular area of interest that you want to work with. Probably sometimes the standard deviation and the mean, you might want to compare those two for that particular NDVI climatology, just to compare the mean and the standard deviation. It can also be done. And you can only do that by clicking on these three dots and clicking on the comparison tool. Once you click on the comparison tool, it will automatically duplicate the data for you. So you see we have a NDVI climatology here. One is on the right side. Then if you move on to the top, you see that you have an NDVI, another NDVI climatology, and there's copy around this area. That means it has been duplicated for you. And you can let the mean NDVI come on the left-hand side. then the standard deviation for the January will also come on the right-hand side. Or you might want to compare the count for that particular period also. So you can change the count for the standard deviation. So if you scroll down, you're going to see the count here, the clear count. Click on that, then that will be on the right-hand side. And the count also starts from 0 up to 160. So as you can see, where we have clear count of the images, they're also shown there. So all the images that we have for January, you can see the clear count being shown at this area. If you are coming towards the equatorial section, you actually see that the clear count starts reducing as we talk about it. So all these images actually count within the clear count area, and they are there contribution to cloud and also inconsistent of the poor data that we had from Landsat 5. You can actually see the count also there. So that's it for the NDVI climatology. Let me remove the duplicate one so that I get only the last one. And we can turn the NDVI climatology off. So from here, you go to the mean NDVI anomalies, the NDVI and the NDVI anomalies for a particular area that we are working with. So remember with the climatology, we actually had only about 36 images for the NDVI, for the standard deviation, and also for the clear count. But for the NDVI, the mean NDVI and anomalies is not that way. Remember from the formula, we have every monthly mean NDVI. So with here, if you compare the mean NDVI and anomalies to the standard NDVI climatology, you notice that there was no time slider here. But for the mean NDVI and anomalies, you have the time slider here. If you click on it, you notice that for that one, the mean NDVI and the standard anomalies, it started from 2017. So the combination of the Landsat and the Sentinel image to actually generate the mean NDVI. And it's monthly. So if you go to the time slider, you can actually see, if I come to 2013, you can actually see that you have it for 2023, you actually see that you have it for January, February, March, April, all the way up to September. Because October, today is 1st November, so October just ended. So you wait for some time, maybe 5 days, then data will actually be computed on October, data sets will be added to it. And as you can see, for this particular area, you can see that within West Africa, we have dark areas in it. So those areas, we had a poor image for them, so it wasn't able to be computed. And we have the mean NDVI. You can also go for the standardized NDVI anomaly for the whole continent. And you can also check the clear count. You can also do the comparison for the study area, depending on how you want to work with it. And if you find something of interest at the map session and you want to share it with any user, just click on the share and print session. A URL will be generated for you. And once I copy it and I put it in the chat, and you also open it, you're going to see whatever I'm seeing right now, whatever I've done at the map session right now, you're also going to see the same thing for it. So that's it for the map session to actually visualize the anomaly and the climatology. Now let's go to the sandbox. I'm sorry. So within the sandbox, we have actually 2 notebooks that actually guides you on how to use this product. And you also have some notebooks that actually helps you to use the product for applications. But I'm going to take us through the notebook that can actually help us to load these products and use it wherever you want to work with. So these 2 notebooks can be identified in the data sets folder. Once you go into the data set folder, you have the NDVI anomaly. You can also see the NDVI climatology notebooks there. And this data set folder actually gives you a guideline on how to use the notebooks. And from there, you can actually pick it up and apply it in any places that you want to apply it. So if you go into the real world folders, there are a lot of notebooks whereby we've actually applied the NDVI anomaly and the NDVI climatology there. So initially, if you open a notebook, the monthly NDVI anomaly will give you the detailed information on how it was done and some of the things that you can expect from it. So, so some of the important detail, the product name is NDVI anomaly. That's the product name that the computer recognizes, not anything. You also have the measurements that you are expected to see. You have the NDVI mean, the NDVI standard anomaly. You also have the clear count. And the NDVI anomaly actually starts from January 2017, and the spatial resolution is 30 meters for it. 30 meters for it. So as you already know, the sandbox, the most important thing is first to load your packages. If you don't load the packages, none of the codes will work beneath it. So always make sure that you load the packages. Then you connect your data cube, because you are going to use the data cube to connect it. And we have the product name. So this is the product name. The NDVI anomaly is the product name. So anytime you want to call the product within the sandbox or to load it through the data cube, this name is very crucial, because without it, you can never load it. Then you just want to know the measurements available. So these are the names, the data type, the units, and the no data is none. And you have the with the clear count, no data is 0 for the clear count. Then as we know, we define our parameters. This one is using the latitude and the longitude, then the buffer zone and the resolution. Because it's based on Landsat, the resolution is also there. That's for 20. And the time period, the period that we are interested, 2020. So this is the NDVI anomaly for the year 2020. So we load the data. At this session, we are going to load the data. So you provide the resolution, which you already defined at the up there, the long lat and the lat range, which has already also been defined. Then the time, then the progress data key. So it will help you once the data set is loading, to just help you to know the progress of it that we are loading it. So because NDVI anomaly is a monthly product for 2020, 12 time steps were returned for that particular area of interest that we had. Then we just wanted to plot it out. So the plotting actually dealt with two. That's the NDVI anomaly and also the standard NDVI standard anomaly. So the first one for that particular area that was zoomed, you can actually see the NDVI anomaly and the standardized NDVI anomaly for that particular region. And also the clear count, which is very, very, very important, because the clear count will actually affect your results. So you also have to take notice of that. So what we wanted to do was just to work with the phenology for that particular area of interest that we work it out. So the next step was to load the crop mass data set that we had, just to help us mask the crops out of the data set. I'm just talking about the application of it. Then we plot the crop phenology for that particular area using the NDVI monthly data set that we had. Because this is a monthly, you can actually see that the curve is almost smooth from 2020 January to December 2020 for the study area that we are working with for it. So the area that we had, which is this area, we already calculated the so the product is already there. You just max the crop out of it, then straight ahead we can actually plot it out to see the NDVI for that particular region. So you can also do it at the continental level by just specifying a month. So you have the continental level there. Then you plot it for this for Uganda. So as you can see, this is the NDVI mean for Uganda for June. Yeah, that's 2022 June, and the standardized NDVI anomaly for June for that particular year. And you can actually also compare the NDVI condition over years. So you can also do the comparison using the anomaly to do the NDVI, comparing it over the years. And as you can see, for Uganda, they had a lot of stress on their vegetation as compared to them having a lot of rainfall from 2017 up to 2023 January. So these are some of the applications of the NDVI anomaly, and you can try it for your study area. One good thing is it doesn't waste enough resources because you don't actually have to do the computation. The products are already there. So just call the product, work with it, and get your results, as you can see from the NDVI anomaly. The climatology also follows the same procedure as we did for the NDVI anomaly. So this is the product name. You have the measurements. Then you have it from 1984 to 2020. So you just look at the measurement. Just as you said, this one is actually only 36 images for the, if you combine the standard deviation, the mean, and the count. Then you load it for the study area that we are working with, the same procedure as we did, then we plot it out. So once you plot it, it is the NDVI climatology mean from January to December. This is just one image, so that you can't get any, it's not as compared to the anomaly, the month, just one image. And you have the standard deviation also from January to December. Forget the year, don't worry, because you've computed, you have to tie it to the middle year. That's why it's 2022, but it's still a range from 1984 to 2022. But the year here is 2002. No, you just have to tie it to a time period, and it picks the middle time period for it. And also the clear count also can be loaded using this for the climatology. So the cropland climatology, you have an example below, whereby you load the crop mass. Then here you are going to plot the phenology curve using the climatology. So this is the climatology phenology curve for that particular period, which is very nice. Then you can also do the per pixel cropping for the phenology, just to see how it actually shows for the start of the season, the end of the season, and the peak of the seasons. So these are some of the examples of what the NDVI anomaly and the climatology can do. But aside this, there are a lot of areas that you can actually apply it, combining it with rainfall data to generate a result, combining it with the water products to also get a lot of analysis out of it. And once you visit the real world example, most of the notebooks here has been changed to support it. So the crop health, forecasting vegetation condition, forest monitoring, mangrove analysis, phenology curve, most of this notebook has been updated for you to be able to use it. So the rainfall anomaly chips also implement it. The vegetation anomalies also implement it. So the NDVI continental product for anomaly and climatology is actually very useful if you want to use it within our study of area. And it can actually also help us to monitor how our vegetation is doing over the period with it. So we'll be happy for you to test it out and use it within your area of interest. Then happy to share the results that you have with us. Then we'll be happy to talk about it on social media. So this is where my presentation will end. Thank you.
Thank you to you, Edward. So much energy, such a comprehensive presentation. It is so lovely to have you presenting on this topic of NDVI climatology and anomaly. Partners, our special guests, Definitely. And you, our users, are a critical part to our success. And we want to thank you so much for your active participation, your support, and your commitment to making these live sessions great. I always say that this is not a secret society. So if you're in remote sensoring in the Earth observation space and you know your colleagues or your fellow students who could benefit from these live sessions, please pass on our weekly invitations to them so they can be part of this community, because we do not want to leave anyone behind. And a reminder that we host these sessions in English and in French. So do not worry if you prefer French, we do have the sessions in French, and we certainly want to connect with you. On the topic of connection, on the screen now is the various ways that you can connect with us, because we certainly want to connect with you. Our website is www.digitalearthafrica.org. You can also send us an email, and this is a general email to everyone, and then it will be delegated to the correct person. That's info@digitalearthafrica.org. We're also on social media by the same name, Digital Earth Africa, and that is on Twitter, LinkedIn, as well as YouTube. And a reminder about those online courses, if you want to get started on your journey, or you're already advanced within the space and looking to upskill yourself in perhaps a different area, please visit learn.digitalearthafrica.org, and you may find a course, or will likely find a course that interests you. It is available in both English as well as French. It's been an absolute honor to host you. Every Wednesday, we have these sessions. We alternate between English and French, and it starts at 11 a.m. GMT. So this week was in English. The one following next week is going to be in French. If you prefer that language, we have you le mercredi prochain, next week, Wednesday, à la même temps, at the same time. I want to thank you so much for your time, your attention, your active engagement. This was probably one of the most engaging live sessions we've had in a long time. Thank you so much again to my colleague, Edward Boamah, for making this possible. We want to see you again here as a presenter, Edward. The sentiment was that you were that good, so please do not be a stranger. We definitely want to see you again. But until we meet again, either next week in French or in 2 weeks' time, which will be our next English session, take care, be safe, have yourself a very good morning, a good afternoon, a good evening, and a good night, depending on where you're joining us from. Thank you and take care.